Hello and welcome to Simplilearn. My name is Jitendra, and today we are going to talk about an algorithm called as the decision tree algorithm. So in this course, we're going to talk about the following agendas. We'll discuss what is decision tree algorithm. Then we'll talk about the few terminologies that are used in decision trees. We'll then try to work around with how does a decision tree work. We'll do some mathematical calculations. How do we find out the decision tree is created with using the best split method of information gain? Then how is the prediction achieved through decision trees? Then we'll build up a decision tree with a sample example. Then we'll talk about some advantages and disadvantages and real world applications where decision tree concept is used. So let's move on. So we have some quick questions. So what type of machine learning algorithm is a decision tree primarily used for? So what is a decision tree algorithm? When you talk about a decision tree algorithm, it's a kind of process or it's a machine learning modeling strategy that allows us to perform a non-linear modeling with non-parametric functions. Now, when I say non-linear, that means it is an algorithm that can detect a non-linear patterns in the data, as well as it is a non-parametric algorithm wherein it does not assume or it does not require any kind of pre-assumptions for the data. Just like we do not require to have a normally distributed data for this, or we do not require a standardized data for this. It's fine if the data is not in a proper format or not in a standardized format. It's also fruitful to work around with this particular algorithm with such type of data, right? It is more or less a kind of an algorithm which works on the principle of creating up a decision based upon a condition. So every time we have to take a decision, and then based on the decision, we move on to the next layer or next level of decision making process until we reach to the final conclusion. So this entire decision making process in the decision tree is divided on the basis of three different nomenclatures. I would say that the first or the starting point is called as the root node, which is usually representing the entire data set that we have. Then we have some certain decision nodes on which we split the data and create up the subtree part of it based upon some conditions. And finally, we have the leaf nodes, which are the final outcomes or the predictions. So you can say that leaf node represents the target variable of the data, typically in a classification or a regression problem. Now the question arises, how will the decision tree make the learning process? So it does the learning process by taking up the part of data. Now, how does it choose the part of data? That's a detailed process. We'll discuss that in further in this lesson. But it divides the data based upon a condition, and that condition will try to generate, or that division will try to generate the data partition in such a manner that the amount of error or the amount of uncertainty that we have in a decision making process, that uncertainty gets reduced by further splitting. Now that needs to be explained through an example. The idea is that, suppose for an example, at one point of time with the full data, I am uncertain to take a decision. Maybe the full amount of uncertainty can vary depending upon problem to problem. But if it is a binary classification problem, the amount of uncertainty can be a maximum of 50% uncertain. Because if you are 50% uncertain, then you have an equal mix of the binary class. Then you will be having a 50% uncertainty or 0.5 uncertainty value. We also term that as a Gini impurity. We'll discuss that later. So that impurity needs to be decreased. And we need to reach out to that impurity in decision making process to a level 0. So until we reach the level 0, the decision tree process will keep on continuing splitting my data and tries to reach out to an impurity level 0. And in each step, it looks for the maximum information gain. When you say the term maximum information gain, the information gain is nothing but the change in impurity or change in indecisiveness that we have at one particular level. We will have maximum indecisiveness, whatever is possible at the start when we have not done anything with the data set. So we will have the maximum, whatever the information loss or or whatever the impurity that we have in the data that would be available at that point of time. And we need to further decrease it down to the level 0. Now, for this purpose, it is always evident that we would require to split our data. Now, there would be usually multiple number of features in a data set, and out of those, you need to think of which feature is the feature to start splitting the entire set. So we need to choose out the best possible feature out of the given features, and that is done by iteratively calculating the information gain for every single feature. And whichever feature gives me the maximum information gain, we'll choose that feature. Now, how is that information gain calculated? So in order to calculate the information gain, we need to measure the impurity on the full data and then find out the impurity when we divide that data based upon a particular feature or a particular condition. When we do that division, each subset of the data that is being created, each subset will provide a certain different level of impurity. We'll take the weighted average of the impurity of the number of splits that are being done, and we'll check with the weighted average of, or rather weighted sum, I should say, the weighted sum of the impurities at the splitted level to find out what is the impurity at the split level. Once we get the split level impurity and we compare with the impurity without the split, that is with the entire set remaining, we should see a decrease. Now that is repeated for every single feature. And once we see the maximum difference in the change in impurity, we choose that particular feature to be the feature to be splitted at. Now, if we are working on the entire set, the first feature that we choose to split the data is called as the root node, because root node will be the first feature on which we'll split the data. After that, we'll get certain number of branches. We'll pictorially look at that. After that, we get certain number of branches. Each branch subset of the data will now act as a subtree or subdata, and we need to repeat that process on that subdata, and again considering that particular data point as the entire set, find out the impurity on that particular branch and do the split again on any number of the features available. It's a repetitive process. Let's move on and understand the key terminologies. Like we have root node, right? So in every tree we will have a root node, decision node, and leaf nodes. Root node is the starting point, as I've said before, that represents the entire set. The splitting process splits the root node or divides any particular node. It can be a root node or a decision node that requires a split. So that root node or a decision node will be splitted up, and that process is called as the splitting process, splitting of the tree. Then we have decision nodes where we take up our decisions, right? So the decision node are those nodes which are splitted up further as well based upon the decision that has came up. Then we have leaf nodes, as I've said before. These are terminal nodes or the final nodes in my outcomes, and that usually represents the target variable of the data set, because of which it is not further splittable. Then another term that is called as pruning. The pruning of the tree means it's a very simple concept in decision tree algorithm. It talks about the process of controlling the growth of tree. There are two types of pruning that we do in decision making, in decision trees. One is called as a pre-pruning methodology, and the other one is called as the post-pruning methodology. In pre-pruning methods, we do not allow the tree to grow itself at an initial stage. And in post-pruning, we take up the process to allow the tree to grow in full and then cut down certain branches of the tree so that my tree is not anymore an overfit. So we try to do the overfit or resolve the overfitting problems using either pre-pruning or post-pruning. This can be co-understood with the concept of early stopping as well. So how does a decision tree work? So we're taking a practical example to understand how does my decision tree is going to work. So consider this data set. We have income, credit score, and status. So it says that if your income is high, credit score is high, status is approved. So we have two classes here, target variable classes approved and rejected. If you look at the amount of uncertainty, you can think in terms of probability of the loans getting approved, irrespective. It is out of 4 cases, there are 3 cases which are getting approved and 1 case is not getting approved. So the probability of cases getting approved is uh, 3 by 4, and rejected is 1 by 4. We will utilize these probabilities and find out the amount of impurity based upon either Gini impurity or the entropy formula for different features. So at root node, we need to think of two features. We have two features, either the income or the credit score. So should we split our income or should we split on the credit score, right? So we need to decide whether should I split on income or should I split on credit score. For the decision nodes, either income is high or the credit score is high. That is one decision. If the decision income is high, credit score is low, it's still approved. Income is low, credit score is high, it can be approved. So these are all decision node criterions. These are four scenarios. How will that really? So how do we measure the best split on that? As I talked about the Gini impurity. So it is a measure of mix of the nodes. How much impure is my decision making process in the data or in the target variable, right? In a typical classification problem, we will have, let's say, if you take a binary class classification problem, you will have two classes, let's say class A and class B. Now, if, let's say, in our case, we have three examples for approved and one example for rejected, right? So, we have a 75-25 ratio. So, there is a possibility of 75% chance of approval and 25% chance of rejection. So, it's a log measure, to be very precise, a squared probability measure. So, the amount of impurity can be given here as 1 minus, to be very precise, let me just get hold of a pen. Okay, so I've got a hold of this now paint window, so I can try and write down a few things. So suppose in my example, we had four number of cases. There were four cases, out of which there were three cases that were getting approved, and there was one case that was rejected. So when we talk about the probability of being approved, that goes to be probability of being approved is 3 by 4. That's the probability of class A, approved class, is 3 by 4. And the probability of class R, that's the rejection probability, is 1 by 4. Now, the Gini impurity, the amount of impurity present or amount of indecisiveness present, is given by this formula. The formula is, that's going to be 1 minus sigma I is equal to 1 to n probability of ith class. Now, the whole square. So that's typically the formula for Gini impurity. So if I have to take that into my consideration in this example, that's going to be like 1 minus, now we have two probabilities, 3 by 4 and 1 by 4. So 3 by 4 square plus 1 by 4 square. That will be your final Gini impurity right there. That becomes 9 by 16 plus 1 by 16. That's 10 by 16. 1 minus 10 by 16 is 6 by 16. So that is going to be 6 by 16. That equals to 3 by 8. So that is the amount of uncertainty that we have, 3 by 8, in the given example at that junction. So that's your initial impurity level. Good. Now, when we had those examples, we had certain cases of high income and low income. So if we try to split on income, I will consider cases on income. If I split on the credit score, then I'll have certain impurity score. So let's keep this number 3 by 8 into picture and let's go back to the presentation. Okay, here it goes. So that was your information here. High approved. So if I think of dividing the data on high, so we have two high cases and two low cases. We just think of taking income as my root node. So if the income is either high or low, so if the income is high, in both the cases, I am getting the status is approved. So if you think of taking up a tree, so either I can decide. So let me just take this off. Remember that number 3 by 8. That's the amount of impurity when I have not splitted my data. Let's now look at the cases that we have here. When we had taken on income, we had two total number of cases which are high, and there are two cases for low. Now, so if I think of dividing on income, either the income is going to be high or the income is going to be low. But when the income is high, we are making up a decision and we are coming to the leaf node called as approved. If the income is high, irrespective whatever the product score is, that it is approved. So if you look at this side of subset of the data, high side, right, the entropy value there is 0, or the genuine impurity is 0. Why? Because we have only one class which is approved. So that will be 1 minus sigma 1 upon 2 the whole square, or rather 2 upon 2 the whole square. We have two nodes of approved and both the two. So that will be sigma 1 upon 2 by 2 the whole square plus, not sigma, this 2 by 2 the whole square, sigma term goes off. So 2 by 2 the whole square term, and because of which this will finally come out as 1 minus 1, which is 0. So we'll get 0 impurity. Whereas if you think of looking at the low side, at the low side I still have two samples, but one is 0, one is 1. So I'll get a genuine impurity value of 0.5. My impurity value is 0.5 there. Because we have equal number of samples, we are 50% sure that it's approved, 50% unsure it is not approved. So we again need to split that data. And here we can split that data on credit score maybe. And then we can get credit score high and low. Credit score high, credit score low. I'll generate high score, approved, and low score, not approved. And that's how it works. So this is how the decision tree is created up in real world practice. Now based upon condition, that's what we have looked at. Same example is given. Income is less than 0.5, gene impurity, samples is 5, value 3 and 2, approved, and so on. In a similar term, the prediction process. In the prediction process, once we get the decision tree completed for any random different inputs, right? Because it follows a path. So every particular path leads to a decision. It leads to a final decision level. So whenever we give a certain set of inputs that follows the decision making process and tries to reach out to one of the branch leaf nodes, whichever leaf node branch it reaches out to be, that becomes the final answer. So same example, 70% approved. That's 75-35. Another measure to measure the impurity. Now I've given you one of the measures called as Gini impurity. The next measure that is commonly used in decision tree algorithm or in classification problem is called as entropy. Now entropy is also called as log loss. Entropy and log loss are similar things. It actually is a quantification of the amount of randomness. When I say those words, what does that mean? That means it talks about the amount of certainty of wrong predictions. It talks about the amount of uncertainty of wrong prediction. That's something is based upon the, if I make up a particular prediction, then that prediction is going to be wrong. That's the point that impurity measure of entropy means. So it tries to consider the same thing. Essentially, that can be given by the formula minus of sigma per probability of ith class give log to the base probability of ith class. Very simple example. I'll work back through with this example. This is a common data set available that's called as the weather data in the field of machine learning. And one of the problem statements is the task is to determine the play tennis. There are 14 instances, 9 yes, 5 no's. It's mixed or pure. Where besides splitting, we need to think of this. There are 9 yes and 5 no's in the entire data set. So if you think of the probabilities of each class, probability of yes is 9 by 14 and probability of no is 5 by 14. You got those approximate probabilities. Then we apply the entropy formula onto that. That's the amount of randomness or disorder in the data. So that is H of S. Usually H is used or E is used to showcase the entropy. So probability of yes log to the base 2 probability of yes plus probability of no log to the base 2 probability of no. We'll get certain values. 0.94 is the value after we apply the formula. Then how do we interpret this? It's a very high entropy. Very high entropy means you will get an entropy value 1 when you have an equal distribution of the class. Both the classes are equally distributed. So high entropy means a mixed and uncertain. So we need to split the data. So how to choose the best split? So in order to do that, we need to look at the information gain. So the entropy at the node or the last starting stage when we have not split the test 0.94. Now if I change my entropy and if I let's say divide on a particular feature, that's child 1 and child 2. If I split on feature 1, I get 0.5 entropy. If I split on 2, I get 0.3 entropy, right? So my average entropy, if I split on this, is going to change like the average of those, considering each of these child 1 and child 2 has equal responses. So 5 plus 3, and the average will take up 0.4. So from 0.94, I'm coming out to an entropy level or error level of 0.4. that brings my information gap value to 0.54. So now that's outlook, and then we have 5 instances, 2 yes, 3 no's. That brings entropy level 0.97. I get this much change in weight. Overcast, that much change. Rain, I have that much change. So overcast, I have 4 instances, or I belong to 4 yes. So entropy is 0. 0 entropy means I have a pure node. 1 entropy means completely impure node. That's how a tree will look like. So outlook, sunny, humidity, high, normal. Then wind, strong and weak, and the overcast condition. Some advantages and disadvantages of decision tree. Decision trees are very easy to interpret, and it can be easily understood by anyone because they are based upon the basic fundamental principles of life. Every now and then when we take up a decision in the real world, it's based upon certain situations and conditions, and based upon that we follow the best possible path. That's what decision tree in machine learning also does. Again, another advantage, it's used for both regression and classification. It can handle both categorical and numerical data, right? No pre-processing. As I said, that it's a non-parametric algorithm. The disadvantages include it's very prone to overfitting. Why? Because if you allow the tree to grow in full, it will try up to a maximum level to achieve the maximum correct answer. So it's very, very prone to overfit, getting overfitted. That's major problem with this decision tree. If the data is changing by a very small margin, entire decision tree might change. So small change can bring up a huge change in the tree, and the entire process might change. That's another disadvantage. It can also be biased. If there's a class imbalance, it can get biased. That's another disadvantage. Let's talk about some real world things. In real world, we use decision tree for the loan approval predictions. We have seen that example, medical diagnosis. You can use it for breast cancer classification or any kind of disease diagnosis that can be used based upon the given inputs of the medical reports. Customer segmentation, like for marketing, we can use for customer segmentation. We can use for fraud detection, marketing analytics. It can be used up anywhere. Essentially, any kind of classification problem where there is a non-linear data, you can always rely on decision tree. The only problem with decision tree is being overfitted. So if we apply overfitting measures like pruning of the tree, or we can use multiple number of trees algorithms like random forest or gradient boosting, or you can use XGBoost, AdaBoost models, then also that will be very, very helpful. But decision tree is one of the basic algorithms that is very highly and widely used in advanced level algorithms too. Thank you very much, team, for giving your time to listening to this. If you have further questions, we request you to put up your questions and remarks into the comments. Thank you very much. See you soon. Have a good day. Bye-bye.